Good afternoon, ladies and gentlemen. My name is Ernesto Hartikainen. I'm the CEO of Biocode. Biocode is the carbon footprint calculator for food brands, producers, and farmers. Welcome to this Biocode webinar on navigating scopes 1, 2, and 3. Today, you'll learn how you can make the complex world of greenhouse gas accounting so much more easier. I've been working with climate solutions my entire career, leading Biocode now for the past 3 years. Before that, I led the Finnish Innovation Fund Citrus Climate Solutions focus area, looking at how Finland can become more ambitious in terms of climate change and what kind of solutions, both societal and business solutions, would be needed to meet these challenging times.
And hi everyone, I'm Evelina Heikkala. So nice to see you all here. I work in Biocode as an impact assessment specialist, and I graduated recently from Aalto University from the field of water and environmental engineering. And I'm also very passionate about climate subjects. And here in Biocode, in practice, I'm working with carbon footprint calculations, company level assessments, and primary production emissions assessments. And hopefully you will learn a lot of new about how your company can actually assess the scope 1, 2, and 3 emissions.
So what will we be covering today? We'll introduce you to the topic of scopes 1, 2, and 3. So what are they in practice? We'll look at some of the standards, the EU regulation that is driving this necessity for companies to report and account for greenhouse gas emissions. And then we'll actually look at how companies in practice can build their own greenhouse gas inventories. We'll do this through a case study of one of the companies we've been working with, Kinnusen Mylly. Evelina will be telling you a bit more about some of the challenges that companies might face, but also how to overcome these obstacles. And finally, we'll explain why you should care. What are some of the benefits for your business for doing scope 1, 2, and 3 company assessments? Let's start with some of the regulation driving this activity. The European Union Corporate Sustainability Reporting Directive is one of the main regulations that is driving companies to report on their greenhouse gas emissions and in sustainability in general. The EU CSRD will become mandatory for many businesses after 2024. It is seen that up to 50,000 European companies will need to start reporting more in-depth in relation to their greenhouse gas emissions. This is mainly in the first phase for large companies, but also stock-listed SMEs. But regardless of this, even unlisted SMEs will be impacted, as their own suppliers, partners, customers will require this type of data from them. Even though this regulation is coming, companies can get prepared in advance, and today's seminar will be telling you a bit more about how you can be better prepared. One of the frameworks that gives good guidance on how to build these greenhouse gas inventories is the GHG protocol. This is a global framework that assists companies on doing greenhouse gas accounting, whether we talk about company level, product level, or value chain emissions. So the greenhouse gas protocol publishes a set of different standards. The corporate standard, which is the main standard when we're looking at scope 1, 2, and 3 emissions, but there are others as well, such as the product standard, and the most recent one on the land sector and removals guidance published this year. So this gives a good framework to get started.
And now that Ernesto has told you about what the GHG protocol includes, now let's go through the reporting requirements that the GHG protocol sets. So the emissions should be calculated for 7 different greenhouse gases, which include carbon dioxide, methane, nitrous oxides, and then different kinds of fluorinated carbons and compounds. And as listed here in the slides, the last two ones are not that common in food sector, whereas, for example, HFCs are commonly used in refrigeration systems and air conditioning equipment, and PFCs are used in plastic packaging. And one thing to note here is that the result should be presented in metric tons and in CO2 equivalents, meaning that you should report the actual amount that has leaked from your pipes or that has been emitted to the air in metric tons. And in addition, you should use conversion factors to convert, for example, the amount of HFC to tons of CO2 equivalents. And then secondly, the fossil and biogenic emissions should be reported separately. So fossil emissions arise from, for example, when you burn coal, oil, or use natural gas and diesel, and they also arise from manure management. And then the biogenic emissions, they arise from burning of biomass, biogas, or any other fuel that is generated from or made from plants or animal origin. And the reason why these biogenic emissions should be reported separately is that the biogenic carbon cycle is relatively fast, meaning that the carbon cycles between plants and atmosphere in a range of few years or a few decades. So the effect is more, it happens more faster phase than that of compared to fossil carbon cycle. And then the result should be allocated by scopes 1, 2, and 3. So this means that the 7 different gases should be presented in tons of CO2 equivalents and in metric tons. And as said before, the emissions from fossil sources should be reported separately and the emissions from biogenic sources separately. And one thing to note here is that the biogenic emissions are not included in the scopes, but they are reported outside them, but they should be still included. And then, how do you actually calculate the GHG emissions? So basically, the equation is as follows. So you need activity data on, for example, your fuel consumption, raw material usage, and waste generated in your operations. And then you will need emission factors, which tell you the climate impact of a specific activity variable. And next, we can take a look at the different sources of the emissions. So the emissions arise from different sources, and they are divided in the GHG protocol into 3 different scopes, and this helps you to identify the actual sources of the emissions. So scope 1 covers the direct emissions from company facilities and vehicles. And scope 2 covers the indirect emissions from purchased electricity, steam, heat, and cooling. And scope 3, it covers all other indirect emissions from upstream and downstream activities. And next we can take a deeper look. So here we see that the scope 1 and scope 2 categories, they seem to be quite straightforward, as we see that there are only a few subcategories that you have to take into account in the calculations. But then when we look at the scope 3 category, we see that there are a lot of different subcategories that you should take into account. So next, let's take a look at the scope 1 emissions more thoroughly. So scope 1 covers the emissions released from directly from company facilities and vehicles. And the subcategories for this scope 1 are burning of fuels, mobile combustion, process sources, fugitive emissions, which means, for example, leakages from pipes, and then agricultural sources. And these emissions arise from, for example, companies' own electricity and heat production, mobile sources, then industrial processes which release, for example, methane in chemical reactions, and then leakages from pipes, and then manure management, which releases methane and nitrous oxides. And then scope 2. This describes the indirect emissions which are associated with purchased electricity, steam, heat, and cooling. So depending on the electricity source, the electricity or energy source, the energy generation produces emissions, and these emissions are accounted for in here. And these emissions shall be reported with 2 approaches, which are the location and market-based methods. The location-based method reflects the average emission intensity of local electricity grids. So it tells you what your company is actually emitting to the air. So here you will have to use the grid average electricity emission factors for a certain country. And the source of electricity has no effect on the emission factor. So whether it's renewable or fossil energy, the emission factor will always be the same. And then the market-based approach. This reflects the impact of companies' choices on the emissions. So if your company uses, for example, electricity made with wind power or solar panels, the emission factor will be lower compared to that of, for example, electricity, which is made from coal or oil. And then we can go into the scope 3. So this category covers all other indirect emissions that the company itself doesn't produce directly, but which the company is responsible of. And this scope 3 is divided into two different categories, which are upstream and downstream. And one thing to note here is that the scope 3 emissions might usually be the most laborious to assess. But let's go forward and see what are the upstream emissions and downstream emissions. So upstream describes the emissions that occur before a company's direct control, and downstream emissions are emissions that occur after the company's direct control. And some typical activities and subcategories for scope 3 upstream activities are, for example, purchased goods and services. So, for example, if your company uses raw materials that you purchase from another company, the production-related emissions are accounted for here. Then upstream transportation and distribution. So, for example, the delivery of the raw materials to your facilities. Then waste generated in operations and employees' business travels, for example, flights and hotel nights. Then employee commuting and upstream leased assets and investments. And then the last category here is the fuel and energy-related activities, which are not accounted for in scope 1. So let's take an example. So if your company uses, for example, diesel to produce heat, the burning-related emissions are accounted for in scope 1. But here in scope 3, you should account for the production of diesel, distribution of it, and also waste generated in the production process. And next, we can take a look at the downstream activities and the subcategories of this. So this includes the downstream transportation and distribution to, for example, different shops, stores, and customers. This also covers the processing of sold products. So, for example, if your company produces cereals, maybe your customer will be using it to produce, for example, bread, and these processing emissions are accounted for here. Then also use of sold products. So, for example, electricity that the customer has to use in order to use your product. Then end-of-life treatment of sold products, so whether it's recycling or other disposal method. Then downstream leased assets, franchises, and investments. So now that we have covered the emission sources and how they are calculated, is it actually then that straightforward? So when we look at the category scope 1, and for example, the mobile combustion or fuel consumption, it is pretty simple because only you have to collect the data of your fuel consumption and then find the correct emission factors. And same applies to scope 2, because now you know what's the difference between the market-based and location-based emission factors. You'll be able to separate which kind of emission factor you have to use. And then when we go to the scope 3, we saw that there are many categories that you have to take into account in the calculations. And in some cases, you might not be able to just use emission factor and activity data equation, but sometimes you might have to model the emission factor yourself. And this applies to, for example, to meat and, for example, fish production. So if your company is buying raw material, say meat from a farmer, they should have calculated the emissions that are related to the production of the meat themselves, because that's a more complex process. And for example, the manure management emissions cannot be just calculated with this equation, but you need a different kind of modeling approach for that. But then let's go forward. So Ernesto will next tell you about some standards, EU directives and protocols that steer in the assessments.
Thank you, Evelina. Evelina introduced you on what scopes 1, 2, and 3 are. But how do you know whether you're doing these calculations and assessments correctly? So we've collected a couple of other regulations that are directing this activity and some of the standards you should be following. In terms of directives and frameworks, we already introduced you to the CSRD directive that is upcoming, but there are others as well. The EU taxonomy regulation sets guidance for financial sector organizations and their requirements for reporting on the sustainability of their investments. This also puts pressure on industrial companies. The EU Green Claims Directive will require companies to substantiate their environmental claims. The purpose of this is to try to minimize the amount of greenwashing happening in the markets. Finally, companies that want to be ambitious in terms of their climate action can set targets in line with the Paris Climate Agreement of keeping global warming to well below 2 degrees Celsius. The Science Based Targets Initiative is a framework for this. In terms of standards, the GHG protocol has the corporate standard for doing company level assessments and accounting for scope 1, 2, and 3 emissions, but also product level standards. In addition to GHG protocol, we have the ISO standards. ISO 14064 and 14067 are some of the examples of international standards for greenhouse gas emissions accounting, whether we're talking about company level or product level assessments. And finally, I will also raise the International Panel on Climate Change's guidelines for national greenhouse gas inventories. So just like companies will be required to report on their emissions, all countries that report to the UN also build national greenhouse gas inventories. Even though these guidelines have been mainly built for countries and their reporting needs, they are also applicable in many instances for product and company level assessments. So I do recommend you look into those as well. Now, we have the regulations, we have the standards, but how can companies do this in practice? And we'll explain a bit more about this through a case study with Kinnusen Mylly, one of our customers. First of all, to conduct a company scope 1, 2, and 3 emissions assessment, the company needs to define its organizational and system boundaries. This means, what are the emissions that a company needs to account for? This needs to be defined. What activities should be included in this greenhouse gas inventory, or what activities are not included, so are excluded. But if they are excluded, explain why. Thirdly, you need to collect activity data to be used with emission factors. So just like Evelina explained, what are the activities the company is doing for producing its products and services for the market. After building the greenhouse gas inventory for a company can analyze what are the major sources of emissions so that a company can try to have an impact and reduce those emissions. Also analyze sensitivities, how much sensitivity is on the type of activity data that is collected, or perhaps on the emission factors that are utilized in the calculations. Finally, a company can report on the results. There are different audiences for reports, whether it's the regulators, whether it's a company's own partners or customers, or even consumers. Now let's look more in depth into a very practical case, the case we had with Kinnusen Mylly. Kinnusen Mylly is a medium-sized company up north, close to the border of Lapland in Finland, and they produce various kinds of cereal products. So flours, other types of cereal products, and also feed products from some of the side streams from their activities. We assessed their scope 1 to 3 emissions for the year 2021 that would serve as a reference year the company can then utilize to set future targets for reducing emissions. Kinnusen Mylly is an interesting company also as they have contract farmers. So they have a very close link into agricultural activities. And once we go into the actual case, you will see that the vast majority of their emissions actually result from agricultural activities. So the production of the grains they utilize as their raw materials in producing their own products. For defining the calculation boundaries, so what are the activities that are taken into account when building the greenhouse gas inventories? A company can look at three things. They can look at the equity share. So if a company has ownership in other organizations, what share of ownership does a company have in these? A company can look at whether it has financial control over other organizations, and if it has, it should account for the emissions of the organizations it has financial control over. Or a company can look at the operational share. So look at what are the activities that are part of the company's operations. In the case of Kinnusen Mylly has an oat mill, a feed mill, a shared facility, and we look at all of the activities that result from these various mills and shared activities, and then build the greenhouse gas inventory from these activities. If we look at the results of Kinnusen Mylly's assessment, you can see what all of this work results in. We have the separation of the greenhouse gas emissions of Kinnusen Mylly separated into scope 1. So those were the direct emissions from own activities. Scope 2 in both a market-based and a location-based approach. And then the value chain emissions, the scope 3 emissions. In terms of scope 1 emissions, in this case, 148.2 tons of carbon dioxide equivalent result from the energy production at the mill, as well as some of the mobile combustion that is required for transportation. In terms of scope 2, there is a very large difference between whether we look at the market-based or location-based approach. In terms of market-based approach, Kinnusen Mylly has its own energy production and mainly based on the biomass burnt from the grain wastes at their mills. So this is a renewable and low emission energy source. For their location-based emissions, the substantially larger emissions result from the utilization of a national average for grid electricity purchased by Kinnusen Mylly. And in terms of scope 3, because of the nature of the company's activity, so the production of cereal products, Kinnusen Mylly buys a lot of grains, and the utilization of an emission factor for an average grain in Finland has been utilized in this case, but down the line, one could also utilize primary data. So go into producer level assessments of individual farmers and their carbon footprint and greenhouse gas emissions from producing these raw materials. So what are some of the typical challenges a company might face when building these inventories? Here's Evelina to tell you a bit more.
Yes, you can change the slide again. So one challenge is the data collection. So collecting data on companies' activities is indeed one of the most important, but also one of the most resource-intensive phases of building an inventory. So it's very important that you know your company's processes and suppliers very well, and that you can allocate, for example, responsibility for different people who can collect the data regarding a specific industrial facility, for example. And then one point here is also that the data quality also defines kind of the quality of the results. So this introduces us the question of primary versus secondary data. So primary data is the one that you can get straight directly from your customers and from your suppliers. And for example, the electricity data that you can get from your own electricity monitors. But sometimes that primary data is not available. And then you have to rely on, for example, statistical averages, which might be fine if you have assumed that, for example, some operation or some emission source is not that big and it's reasonable to use secondary data. But in a nutshell, you should prepare for the data collection well in advance and do it systematically throughout the year. And then emission factors. So there is a vast majority of different literature references and databases from which you can choose the emission factor from. But it's important to know that, for example, when you're looking at an emission factor database, there might be similar kinds of emission factors that you need, but they differ from, for example, in calculation assumptions, how the system boundary is defined, and this brings some kind of like differences to the emission factors. So know what you're looking for, and then you can choose the right emission factor. And additionally, there are different frameworks that provide the different kind of emission factors. So for example, in scope assessments, we need to use different kind of emission factors for different scopes. But then, for example, when we're assessing the product carbon footprint, we should always use the life cycle assessment method for the emission factor. So, for example, the example about the diesel that we introduced previously. So in LCA approach, you would need a different kind of emission factor that tells you the impact of diesel production, burning, and all of the life cycle stages. However, in scopes, we have to use two different kinds of emission factors. So, but now that you know what is the difference between different approaches, and you know that you're looking for the specific kind of emission factors, you can be sure that you will collect the right one. Then available resources. So for a thorough and good assessment, you will need enough skilled human and financial resources. And also, your company can choose whether it would be reasonable to do it in-house with your own expertise or use external service providers. So this thing also is a decision that you have to make, and also well in advance, so that you can prepare for the assessments. And then lastly, the level of uncertainty. So as in all calculation assessments, the data quality and accuracy of emission factors will bring some uncertainty to the results. But however, there is a good rule of thumb. So you could compare your sub-results to, for example, literature values, so that you can validate that you have used correct kind of data, and so that you haven't forgotten any zeros of your activity data values, and that the emission factors seem to be reasonable. And then also, how to get ready for scope 1, 2, and 3 assessments in a nutshell. So as said before, reserve enough human and financial resources for the assessments well in advance. And also know your company's operational boundaries and all the activities well. So if you have like many industrial facilities, or if your operations are locationally distributed, be sure that you have people who can collect the data that you need. And then start demanding data from your suppliers well in advance. Maybe you know all your suppliers well, but are you sure that they have all the data in hand that you need? So start demanding that well in advance as well. And then finally, you can evaluate whether the assessment should be conducted in-house, so with your own expertise, or should you maybe use external service provider as a help to do the assessments.
Thank you. Now, finally, why should you care? Why should companies pay attention, especially now? Well, some of the benefits you can get from conducting greenhouse gas emissions accounting is that you are prepared when these regulations come into force. Your buyers, your customers might need this type of data, and you do not want to be in the position where you are not able to provide this data and lose sales because of that. Even though unlisted SMEs don't face these direct requirements, they will also face a growing pressure on providing this type of information from their own stakeholders. Companies can also utilize this substantiated environmental action in their own marketing and communications, but they need to be backed with real data so that there is not a chance of misinterpreting those claims. Finally, we want to tell you a bit more about Biocodes and our solution. So we want to simplify and streamline greenhouse gas accounting. And for that, we are launching our greenhouse gas calculator for company level assessments so that you can make it easier to account for your scope 1, 2, and 3 emissions. You can reach out. You can visit our website at biocode.io to learn more.
Yes, so thank you for your participation. And we hope that you got some new insightful information on how to calculate the emissions. And next, we are happy to answer your questions if you have them in the chat. And we will also send you the materials to your email afterwards. So thank you.
Thank you very much, and hope to see you soon.